Next, we are going to talk about storage device hierarchy. Some of you may already heard about this from a computer organization class. The figure shown in this slide, from top to the bottom, the unit cost will be reduced. However, the speed will be decreased. So since the unit price reduced from top to the bottom, the size becomes larger and larger from top to the bottom. And also, the hierarchy can be divided into two groups. Above this line, we call this group as a volatile storage. So volatile storage means the power is required to maintain the information. If the power is out, all the information will go away. And below this line, we call this group as a non-volatile storage. So for this group, the power is not required. So even without the power, the information can still keep in the storage for a pretty long time. And also for the non-volatile group, actually can further divide it into two parts. For solid state disk and hard disk, these two actually we also call them second storage. And for the optical disk and the magnetic tapes, actually they are called tertiary storage. Caching is a very important mechanism. So when we talk about storage, the idea of caching is that so we copy the frequently used information from slower storage to the faster storage temporarily in order to improve the performance. So from this description, we know that the operating system is not only consider the correctness, but also the performance or efficiency. So if we only consider the correctness, the faster storage and the hierarchy structure actually is not necessary because the correctness can be achieved through the slower storage as well. And the caching procedure is like when the CPU requests some information, it will check the faster storage first and then the slower storage. So for example, we have the main memory as faster storage and hard disk as a slower storage. So the CPU will check the main memory to see if the required information is there or not. If yes, the information will be directly retrieved from the main memory. If the information is not on the main memory, the CPU will further check the hard disk and load the information from there to main memory, then retrieve the information from a main memory at the same time, cache the information on the main memory. So when we have more than one storage in the system, we often call the slower storage as a storage and the faster storage as a cache. So let's look back to the previous example. So we have a main memory and hard disk. The hard disk is a storage, and the main memory can be treated as a cache. However, before the CPU does the processing, it will load the information from a main memory to register. So at this moment, since main memory is slower than the register, so the main memory will be treated as a storage, and the cache is register. So as we have mentioned in the previous slide, in the hierarchy, the upper storage is faster than the lower storage. However, the price of upper storage is much higher than the lower ones. So therefore, the size of a cache is usually smaller than the size of a storage being cached. As the development of a computer technology, the computer system architecture evolves as well. So from now 10 to 15 years ago, our computer can only has a single processor or single CPU. So I'm not sure if you guys heard about the Moore law or not. So every 2 years, the speed of a processor will be doubled and the price will be halved. So for a single processor, how to increase the speed? So which through increasing the frequency of the processor. So when the frequency get increased, the temperature gets increased as well. So therefore, we cannot increase the frequency to whatever we want. So because we have to consider the temperature of the processor. So otherwise, the processor will be burned. However, we don't want to stop the development of a computer technology in terms of speed or performance. Then we have the new idea to increase the performance of a computer. So since we cannot increase the frequency of a processor anymore, so how about we just add more processors into the computer system architecture to make these processors run in a parallel manner. And then some students may think that so we can just use the multiple computers to do the same job, then we can achieve the same goal, right? However, we need to consider the cost of multiple computers. So if we introduce the multi-processor system, so these processors can share the same main memory, motherboard, power supply, etc. So it can dramatically decrease the cost compared with the multiple computers. And beyond that, if some processor get failed, we still have other processors to work for us, which can increase the reliability of a computer. So even though the performance of the system is decreased a little bit, but it is still functional. So for clustered systems, it is very similar to multi-processor systems, but just like what we have mentioned, so we connect multiple computers together to do some tasks. So compare with a multi-processor system, a clustered system can provide even more computing power. So beyond that, cluster systems are more reliable than multi-processor system. For example, if one computer in the clustered system fail, we still have other computers can take the responsibility of that failed computer. And also, since the failed computer is a complete unit, so we can just replace it with a new computer. Then the performance of the cluster system um, is recovered as before, so which is even better than multi-processor system. However, the disadvantage of a clustered system is the high cost. So for multi-processor system and the clustered systems, according to how those computers or processors can collaboratively work on different tasks, actually they can be further divided into two types. One is called asymmetric, another one is called symmetric. So for the asymmetric one, among all the unit, so one unit, either it is a processor in the multiprocessor system or a computer in a clustered system, it can dominate the entire system as a boss. So this dominant unit will assign the task to other unit in the system. So when other unit finish the task, it cannot choose another task by itself. It must report to the boss, then get another task to work. On the other hand, for the symmetric one, all the units are the same. So they monitor each other and they choose arbitrary tasks from the task pool. after they finish the previous one. So why did they monitor each other? Because if one unit is failed, so other available unit can take the and finish the task and continually execute it.